Welcome back, welcome back, welcome back to the Clean Water series with Proline Fittings. I'm your host, Justin Giroux, and I promise that is the last time you're going to hear me sing. With me, as always, is our big producer man behind the scenes, Monsieur Marc-André. Say hello to everyone, Marc.
Hey, how's it going?
So, Marc, it has been a very long while since our last episode, and a lot has happened since then.
Absolutely. Been too long.
It's been too long, too long. It's been a crazy year. Global supply shortages, container issues, resin shortages, inflationary pressures just about everywhere, and especially in our waterworks industry. It really has been a mind-boggling year. And, I'm entering into that sort of veteran territory now with my experience. And I can say I have never experienced a year quite like this. But, Proline Fittings has been sort of red hot, hair on fire busy since January, and it hasn't stopped. The scarcity of supply has obviously created some opportunities for Proline, but ultimately it has been our unwavering commitment to delivering exceptional customer service and our focus on product innovation that has delivered our success this year. So, just some of the things that we've done in this year, we've increased our warehouse capacity by over 30%. We added more yard space. We added new equipment and machinery, enhancing our fabrication capability. We've invested in people, doubling our production capability. We've added bilingual sales support, which is, part of our commitment to growing in the Quebec market. And this is just the tip of the iceberg for us here in Eastern Canada. But really, the bottom line is thank you. Thank you to everyone out there who has chosen to partner with Proline Fittings and being part of our exponential growth and success story this year. Today, we have a doctor on the show, which is pretty darn cool. That's a first. He's here to discuss a revolutionary new water sensor technology. But before I get into that, I wanted to quickly recap some things, primarily since last time we were on the show, which was we had our event Tech Aqua. So, Marc, it is hard to believe that Tech Aqua was 8 months ago. It's just, time has flown, but Tech Aqua was quite an event. It took a lot of volunteer hours to put it together, and I have to say, once again, thank you to everyone that was involved. But
Indeed.
what?
And
Yeah.
just the production aspect of it was like I felt like I was spinning about 12 plates at the same time. So,
Yeah, and from Fiberglass Technology Corporation, SPD Sales, George Fisher, Proline Fittings. There's so many folks and companies that were invested and involved in delivering the program. It was just exceptional. And just for those that maybe missed it or weren't aware of it, Tech Aqua was a 100% free live streaming event that we did two things. We provided on-the-job training. We actually delivered over 190 hours of on-the-job training. And it was also a fundraising event that was held on World Water Day, March 22nd. We raised over $3,000 for the Clean Water Education Foundation. And it was a lot of fun. I mean, it was stressful, but it was a lot of fun. And we're really, it was our first one. We're really stoked, excited for the next one happening in next year at World Water Day. It should be a pretty great event. We really are setting the bar high. We've got pretty aggressive goals in terms of the content we're going to deliver and the training,
absolutely.
as well as the fundraising portion. So stay tuned. There's going to be more information on that. But Marc, there is another little loose end that I wanted to tie up here before we move on to the main event today.
Yeah, speaking of raising funds.
Yeah. So for the 2 or maybe 3 people, and that's probably being generous, that have been watching this podcast since
way more,
since
by
day
the way.
one,
Way more.
you may remember my personal commitment to donating to the Clean Water Education Foundation, which, by the way, is a 100% volunteer operated and registered charity. In the second episode, I was pretty caught up with the use of the word about during the first episode. And so I decreed at that time that I would personally donate $20 for every time I used the word about.
Oh boy.
Yeah. And so anyhow, since the inception of the Clean Water Education Foundation, I was involved financially as both volunteer hours. So that part since the beginning, but it is high time that we tally up the abouts and really get the official count. So Mark, do you have a number for us?
I got way better than a number. Way better than a number. I actually have a video where I've did a montage, if you will, of every time you said about during episode 2 of the Clean Water series with the
Oh,
wonderful
please.
Barbara Robinson.
Oh, no.
Yeah, so we have a count and we have video. So without further ado, let's have a look.
Please no.
In tangent with the Clean Water series, we're also establishing a fund to support and promote and encourage education in the waterworks industry. Now, during the first episode, I said the word about 14 times in the first 3 minutes, and to watch that now is a little bit frustrating to say the least. So what I'm doing is on this episode, anytime I say the word about, I'm personally donating $20 towards the fund. And hopefully I don't say about too many times. But enough about that. Let's get to our guest today. I'm wondering about mind if I talk about a product really quick, Barbara?
No.
Sometimes you hear about gaskets in a sewer fitting by misuse. So the other thing about our process is that it's automated. So that's interesting. And do you mind if I talk about a product really quickly?
Yeah.
Get into the details about it, and it's just eye-opening, just the cost. We haven't even talked about the environmental impact, Barbara.
Right. But let me tell you what warms the cockles of my heart.
Mark, I believe, do we have some information about Norton Engineering? Is it available to the folks out there?
That was embarrassing.
Yeah, so I hope you have your checkbook out because so if the audience didn't catch that, and it wasn't really that bad in fairness, but Justin said about 12 times during the episode. So I'm not a mathematician, but doing the math quickly, I think you owe the foundation about $1,000.
Yeah, that's the creative math there, Mark. It's creative math. I especially like how I snapped the bill upside down in front
Oh
of the
yeah,
camera.
that was awesome. That was awesome.
classic. So, all right. Well, yes, $240. I am very happy to donate to the Clean Water Education Foundation. I will be making that donation today with my credit card on the website, which is cleanwatereducationfoundation.ca. Please feel free to check it out. Yeah, and I'm going to post that too, just so that we keep everybody on the up and up. Now, on to the main event. All right. Our next guest holds a Bachelor of Science in Biochemistry from Arizona State University. He holds a PhD in Biochemistry and Molecular Biology from the Scripps Research Institute. He has a wealth of experience in scientific research and product application and development, and he is now the Product and Business Development Leader with Burge Environmental. Welcome, Russell Burge, to the show.
Thank you, Justin. Thank you, Mark, for having me. Appreciate it.
Yeah, so awesome to have you on the show. I mean, we first met at a trade show, and right away I was intrigued and then just fascinated by the topic and the knowledge that you have. And so, let's just dive right in and tell me, what is Burge Environmental?
So Burge Environmental is a company that was founded by my father and his business partner, David Hoffman. So my father is Scott Burge, and they founded this company over 30 years ago. And they've been working on a lot of different sensor technologies. Basically, they've been focused on the worst of the worst environmental pollutants. I mean, you got to think of carcinogenic compounds, things that foul groundwater, things that foul the air, bio weapons, TNT, other things like that. They've focused on looking at sensor technologies that really tries to find the baddies to protect people and infrastructure, especially water and air, and even groundwater and soils. Recently, we focused, and where I come in is we started to look at this new type of sensor technology called it's basically biofilm sensing technology. We call it the MPS, which is the microbial potentiometric sensor. We started working on this a few years ago, and when everybody was hunkered down, and trust me, we were hunkered down too during the pandemic, but we were working really hard, and we actually have now we worked on many different patents. We've been awarded 4 patents, not patent applications, but 4 patents that protect this technology. We got most of those in the last couple of years, and then we also have published 6 peer-reviewed journal articles about this technology in the last 14 months. So we've been very, very busy on this, and we have many more patents coming and many more other publications. So we've been really doing the commercial side, but also trying to spread the knowledge and protect the technology. So we're headquartered in Arizona, in Tempe, Arizona. I'm actually living and working out of, I work out of the headquarters, but I spend a considerable amount of my time here in California, hence the background. And we actually have recently partnered with Capstone Metering out of Texas, and that they're helping us scale and build up our operations wing as we get more and more orders. So we've taken this technology that I said, a few years ago was just kind of, things that we were kind of playing around with in the laboratory. And now we have a multitude of different locations where we're deploying, that we're seeing tremendous success in things like water, drinking water, wastewater processes. And we also have commercial applications in monitoring algae growth. We're looking at plant health, plant soil. So there's a lot of different things that we're doing, hence why we're looking for partnerships and things like that, and why we have this broader commercial partnership with the folks in Texas.
Yeah, it's really kind of blew my mind when you were talking about the different applications for the product, how well it worked, and then also the fact that it's cost effective. So I can understand completely that you would seek patents for such an amazing technology. So just exactly how does the MyProbe E work?
Right. So the physics of it is actually very simple, and but it ends up being a very complex kind of orchestra of different signals. So basically what we do, and why we're a little bit different than everybody else, is that we use the biofilm itself and its ability to create charge. So it's well known that biofilms are electrochemically active. They basically take chemicals, they break those chemicals down, and as many of you know, those chemical bonds are basically held together by electrons. And there's this whole sort of orchestra where the biofilm will take food, it will break it up, and then you have all these electrons and different components of the metabolism that are used to generate more of the microbes in the biofilm. And then of course there are electrons where the biofilm will actually store the electrons separately in a sort of separate metabolic pathway, if you will. And the biofilm itself will create these potentials. And from that, we have a sensor technology that taps directly into the potentials that the biofilm makes. And what's nice about our technology is it's totally agnostic to the type of bacteria, the type of microbes. It doesn't matter. There could literally be tens of thousands of different species, or there could be just a couple of species in the biofilm. It doesn't really matter, because what we're looking at is the physics of the charge in that biofilm. And that's a fundamental principle of what most biofilms are doing. And so what's nice about that is we don't need to dope our sensors. They just go directly into any kind of environment. We've even done this in unsaturated places like dry desert soils in Arizona. But obviously they work best in things like wastewater, where you have liquids that have lots of biological activity. And then that's where we can see the biofilms will develop. They're naturally occurring biofilms. We don't do anything to perturb them. We don't have to seed it with anything. The naturally occurring biofilm goes on there. it changes the way, it basically has this evolutionary aspect to it where it uses electrons in ways that in some cases, we kind of understand what they're doing. And in many cases, we really don't understand even how they're storing some of the electrons at certain potentials. But what we do is we measure that potential. And those potentials are sensitive to two major things. The first one is the metabolism of the biofilm itself. And I'd be very specific to say the biofilm, because it's a lot of different organisms all working together like a big super organism. I mean, think about like a school of fish, and then think about like another school of fish joins that school of fish, and then think about like the dolphins that come, and then the whales that come and eat them, and then the birds from the top, and the swordfish from the bottom. All of that stuff is creating this biological symphony, and we basically measure that as part of the biofilm's basic potential. So we see the metabolism in there. And the other thing is that because these electrons are being exposed to the environment through the biofilm, they actually are sensitive to the physiochemical properties of the liquids around them. So for instance, if the temperature changes, if the pH changes, if the dissolved oxygen changes, all of that, because it's in direct contact with what the biofilm is doing, and the biofilm is acting like the super organism, they're sensitive to those changes. So we measure those without perturbing the system at all. So, we put this in so many different locations and so many different applications, and we always see signals that tell us a lot about what's going on. And the most important thing about this is that no cleaning is required. There's no biofouling that occurs because the biofilm is the sensor. So most people would have to, for most current sensor systems, you have to go in and you have to clean it, you have to calibrate it, you have to do routine maintenance. With these systems, going back to your original point in the question, is they're very low cost as far as the sensors go, and they don't need to be cleaned, they don't need to be calibrated, they don't need to be maintained. We've actually have sensors that have been in sediments for nearly a decade now. And so when we were doing our very, very first test to play around with the technology, we have those sensors that have been going strong, and they're still producing valid data, never have been cleaned, never need to be calibrated. And we get a little bit of pushback about the calibration because people look at us and, if you're an analytical person, I mean, I used to do analytical chemistry in the biopharma industry. And so I'm very familiar with that, you've got to do calibrations, you've got to do your system suitability checks and all that. This is because the biofilm is alive. It's a lot like when you do, unfortunately, we in the pharmaceutical industry, you still do some toxicity studies on, let's say, some organisms, or you do screening on little zebrafish or something like that. And regardless of how you feel about that kind of testing, the point is that it's an organism that actually produces the signal. In this case, we're not doing anything cruel or mean, if you will. If you consider that stuff to be cruel or mean, that's a whole nother topic. But with this, it's biofilms that they do what they do. We don't perturb them. We certainly don't hurt them. In fact, we like it when they proliferate, and we get the information from their biology. So again, you can't calibrate that because they're going to do what they're going to do. We get the signals, and what we say from the signals is basically the changes that we see in how they manage those charges, which is largely electrons. We get a lot of information about that. I think I've said a lot there. So I don't know if you want to follow.
Yeah, no, you have, and it's sorry, I think we just had a bit of a blip there, but just wanted to say, Russell, there's things that happen all over the place in water and wastewater treatment. You've got, in a lot of cases, your municipal operators are spread pretty thin, especially in the smaller rural kind of areas where they have to cover off the, multiple locations. And I can see how the requirement to calibrate instruments in order to maintain that accurate signal and to understand what's going on in your process is so important. So, the fact that you can have your sensor installed for 10 years, I think you said you're one of your original sensors, and it's still producing valid data without having to touch it. That's pretty impressive, and I can see how that would appeal to a lot of folks that that work in sort of these kind of remote areas that are spread thin, as I was saying. So, what happens with sensors if they're not calibrated properly?
Well, that's one of the conversations that we have a lot with our wastewater clientele is that, basically we'll go to some sites and they'll point at a sensor and just say, that one's just simply not working. We don't maintain it, so we know we're not getting valid data. I think that's one of the better case scenarios where people are just straight up honest and say, look, that's supposed to be cleaned, that's supposed to be calibrated in order to give valid data. We need that data to help us make process decisions. We also have heard, from candid conversations with others that, sometimes operators just don't even know about the cleaning procedures and the maintenance procedures. And so
Right.
they're either getting invalid data and they know it, or they're getting invalid data and it's a problem because they think that it's actionable. So we see that quite a bit, and that's the one thing that we're really trying to do is, we're not really setting out to replace any current technology. We are very respectful of the fact that, and like I said, I formerly was an analytical biochemist and chemist. So the data, give me the data, give me valid data, and I can make lots of really important decisions that can help drive things forward. Goes with all of our customers too. So, we'd like for the operators to have lots of different orthogonal techniques that they can use to make those decisions. The edge that we have is that we basically have an immortal sensor. We can put these sensors into locations. Again, the sensor itself is low cost, and it can basically go into any part of the wastewater train. And like I said, we've put it in all sorts of other environments. So it has that advantage that it's low cost. It's extremely easy to maintain because there's really no maintenance to do. Some people even are worried about like rags and things getting on it. The biofilm will still be there. I mean, you obviously will get some muffled signals if there's too much gunk on it. But the point is that, it can't get biofilmed, biofilm, because the biofilm is there. It's not sensitive to temperature, salinity. It is sensitive to certain types of toxic compounds and other compounds that are used in wastewater treatment. But that's a good thing because that's where you can get information about what's happening in your processes. Is it, are you putting chlorine in there? Do you want to make sure the chlorine's working? We've actually published papers on how we can look at chlorine levels. Are there heavy metals that are harming things? Are there biocides? We've published white papers with wastewater treatment operators to show how we can see all that. So it's just it should just be another type of instrument that people use, but they should never have to worry about it.
Right. Yeah, and one of the things that really, struck a chord for me anyway, when we were discussing this in the past, was just how responsive your sensor technology is, and that it can really detect an issue sort of before it becomes an issue. Because I know that, in treatment processes, things tend to snowball, right? When you get certain attributes that are way out of line, it kind of builds on, and then it's really hard to get back to where you need to be in the process. So maybe you could speak about that really quickly.
Yeah, so I mean, one of the things that we're looking at right now is looking at aeration cycles in certain reactors, and we can basically monitor the biological oxygen demand and a lot of other types of properties inside that reactor, and we can get an idea of when the biological oxygen demand starts to deviate from the oxygen level. We can help inform the operator, hey, additional oxygen's not helping because the biology is basically, it's done with that cycle. And that's been a big one for us. We're looking at doing a pilot here in California, and when that's available, we'll publish a white paper, and we may even be able to bring people on site. But the idea there is that it can have considerable savings, energy savings, because those blowers are operating 100 to 500 horsepower, and the duty cycles are significant. So even for relatively small plants, we're talking hundreds of thousands, if not millions of dollars a year going into energy costs. And if you can just shave a small percentage of that, that's a big deal. So that's one of the things that we're looking at in that respect. We also have seen biocides and other nasty chemicals that are getting dumped into the headworks and in wastewater treatment plants. We've published a white paper on that. We admit that we're probably not the only technology that can do that, but we're the best technology that can do that because we can do that very inexpensively. These sensors are very sensitive to all different types of biocides and cleanser compounds and even milk. I know that we've had some customers who have dairy farms that dump, and nothing hurts a wastewater treatment plant like milk and other dairy products. We can see all of that long before it hits the headworks, and we actually have customers who use that data to divert flows so that they don't have operational challenges. And one of the things, it's not published, so I'll only hint at this, but this is really fascinating. We actually do some algae research as well together with AZ Caddy in Mesa, Arizona. It's part of ASU. And we're actually able to see, to your point about, the signals will tell us things before they happen. The biofilm is so sensitive to not just the physiochemical characteristics of the solution around it, but they actually interact with the biology. So in this case, the biofilm interacts with the algae. And we've seen cases where the biofilm reacts very strongly before, for instance, there might be an algae crash or something. And this is a very big deal because if you know when to harvest that algae, you can gain a lot more value instead of losing your harvest. So that's just one example. And we see that in drinking water and wastewater too, but it's interesting to just see how the biofilm actually kind of communicates with the other organisms around it. And just the types of signals that we see tell us something about what's going to happen, not what has happened, not what is happening, but what's going to happen. And that's
predictive information, which is invaluable.
Mm-hmm.
Yeah. And you mentioned algae blooms, and it's true. It was an issue that was reserved for warmer climates, but there's algae blooms now in Hudson's Bay apparently. So it's really become a global problem, and it is one here in Canada. Of course, if you're able to kind of predictively protect the source water, this is something that is really special. So many applications for the product, and you obviously touched on one of the big ones, which is cost savings, right? So we talk about the amount of energy that goes into operating the aeration systems, and the aeration guys aren't going to like this too much, but yeah, if you're able to maybe size down the equipment because your technology is able to be so predictive, and or at least save the amount of time it's running, or kind of prove the value of running your aeration system more efficiently.
Yeah, I mean, I think it's a win-win-win. I can't imagine anybody being on the opposite side of this, because even if you want to build out more systems, more power to you. I want to build bigger, better, more systems that make our infrastructure around the world better. All we're saying is you can do it maybe more intelligently. Like you could maybe even build the same size plant you want, but maybe you're only operating parts of it at a time. And maybe you keep the other parts for when you need to do maintenance, or when there are exceptionally high flows, or you want to build for the future and it's cheaper to build the system now, but in 5-10 years there's going to be 500,000 new people who, some cities in the US, for instance, are growing at an amazing clip. So all of this stuff, it all works together. We're basically saying, use the technology to operate your plants in a way that's good for you and your community, and that's really all we're doing.
Now, your technology is sort of plug and play, is it not? You can just you get all of the components. Explain how that all works.
Yeah, basically the business end is the sensor. The sensor is in direct contact with the solution. I didn't mention this earlier, but we always have an ORP probe and a silver chloride reference, or some sort of reference, because that's how we measure the potentials of the biofilm. We're always comparing it to that reference. So that's your business end. It's basically an industrial ORP. and it's up to 8 microbe sensors per communications box. In the communications box, that's where we have our sort of, this is part of the protections that we have with our IP, the sensor and the communications box, because there are very special ways that we measure the potentials. You can't just, stick a voltmeter on it or something. You just, it doesn't work like that.
There's a little bit more to it than that.
There's a lot more to it. And actually, there's a lot of different ways that we can measure the electrochemical properties. But the point is that in that box, we currently collect the data, and then we send it to the cloud. We have a cloud platform that we make available to all of our customers. And that cloud platform has dashboards, it has basic analytical capabilities, and it has the ability to text you or email you if your signals go outside of operational ranges. And that's really where the sort of sweet spot for user friendliness of this thing is, that basically you'll define an area where normal bounds, and then if the signal goes above those bounds, you may have a nutrient spike. That's typical of somebody getting too much ammonia, or maybe somebody dumped way too much nutrient load. And when there are big spikes down from that, we know that's largely due to toxic events, too much cleansers getting into the system. We've had illegal dumping occur, that we've helped our customers manage, that was harming their sites. So those emails basically go to the user, and they go, oh, okay, now I got to kick my my analytical team in gear and figure out what's going on, or can I divert the, hopefully you can divert the flows. Or if it's already in there, you can take corrective action very quickly. And in some cases, we used our systems to figure out who was doing it, and that was really important, because we actually had to do kind of our customer unfortunately had to do some sort of quasi crime scene investigation to figure out who did it. And it's pretty sad, but being able to put these inexpensive sensors all around your watershed and above your headworks is really powerful.
Absolutely. And it's funny, I just read was it this morning or yesterday, there's an issue, and I won't mention where, but in a major municipality in Ontario, there's an investigation happening with some, we'll say, industrial bad apples that are dumping water into the sewer system. And there's all kinds of issues it can create, from high levels of H2S gas, and that's just the kind of the start, right? So if you're able to kind of catch the we'll say the industrial commercial bad apples, and then you can hold them accountable, right? So, and this is another sort of angle or element of your product that is really kind of impressive.
Yeah, and there's two ways to look at that too. It's obviously you want to minimize all these really bad events, but in the end, when our customer found out who it was, there are remediation techniques to make it so that it's not a problem. It's a speeding ticket, it's a fix it ticket. It's not a go to jail kind of thing. But
we work together to fix the problem.
Exactly.
So they may be ignorant to the fact that whatever is coming out of the pipe.
Frankly, we're on both sides of that. We have customers. A big part of why this technology is so important is that both sides. We have this use case where somebody will say, well, my process is working, and the process upstream or downstream isn't, and at the same time you get the opposite happening with the other party. And so what's powerful about this is we can act as a referee. We can put sensors all around, and then we can say, okay, this is where the process is breaking down, and these are the remedial steps that we think you might need to take. So it's just nice to be able to back everything up with data, instead of, we really see that a lot where it's, my process works, that person's process doesn't work. And you ask the other guy or the other girl, it's like the same, it's the reverse. So it's really important. And this is, I think it's a relatively low cost solution to a very valuable problem. Like you said, there's a lot of waters that are going places that just, we can fix it. We can prevent it.
Yeah, exactly. And you have, as you already mentioned, you have the hardware, the software, everything is in the cloud, the information's at your fingertips. you're getting email alerts and text message alerts. Like it's really a complete. You guys have thought of everything, it seems. So
yeah, we've been working at the wastewater game for quite some time, and
Yeah.
you know, we have excellent group of people who don't probably get enough accolades. So I will definitely pat them on the back as I see them, because they've really done a great job. I mean, we're trying to get it even to the point where it's basically a self-install kit. It's not quite there yet.
Right.
But the idea is, I mean, a first-year engineering student should be able to install one of these. I mean, it's really meant to be that straightforward.
Excellent. I kind of quick question for you here. So let's say we're talking about a huge facility in Ontario. We have Ashbridges Bay wastewater treatment plant. It's in Toronto. It's what is it? Capacity of over 800,000 cubic meters a day. What would you expect in terms of the amount of sensors you would need for a facility like that?
Yeah, I forgive me. I'm looking up at my screen here because I actually have a schematic of that plant, and yeah, I mean, it depends on where you can basically put a sensor at every step of the way. You got incoming sewers. You could put probes there and above that. In front of that, there's a pump station. You can put it before and after the lift pumps. And in fact, that brings me to a really important point that we have with one of our customers in Arizona, is we can use these. We've actually been able to infer pump operations based on our data.
Wow.
And what's interesting, because the biofilms are basically affected by what's going on around them. So even flows, even just flows and the types of flows can change. So we can actually alert people whether or not their pumps are operating again in that normal operating envelope. So that's already a very powerful thing. So you can put them above and below the lift pumps. You could put them right after the fine screens. They obviously, my probes don't like ferrous chloride, like any biology, but
No.
the biofilms, this is actually an important point though, is that the biofilms, you can harm them very acutely. You know, you can basically dump poison on them, but the biofilms just grow back because, you know, it's this sort of one man's trash is another man's treasure. The biofilms evolve, they adapt, and there's always going to be something growing in there. Obviously, you can keep the metabolic activity way down, but effectively they're going to do biology. And there's going to be new characters and actors going into the biofilm and taking advantage where others are basically dying. And that's one of the advantages that this, and is why we call it the immortal sensor, is that no matter what you throw at it, it's going to come back. It's actually pretty much impossible to kill biofilms.
You're always going to have those electrochemical responses.
Signals, exactly.
Signals.
Yeah, and response. We call them microbial responses and MPS signals. So yeah, absolutely. And you know, we aerated grit tanks. We put for our customers. We put them in digesters. We put them in primary clarifiers, aeration tanks. That's the nice thing about this too, is because the biofilm is neither aerobic nor is it anaerobic. It's this special super organism that doesn't really care how much oxygen is there or isn't there. There will still be biology occurring, meaning metabolic activity, and the biofilm itself will act in a physical way with the solution around it. And we measure both of those things at the same time, along with a lot of other things. So there could be tons of hydrogen sulfite. It could be completely anaerobic, and we get valid data. On the flip side, you could take that very same probe, you could dump highly aerated water in there, and we've seen this before, both in our customer sites and in our laboratory studies. You know, as much oxygen as you can possibly dissolve in that solution, and we still get valid data, and everything in between, because the biofilm is reacting to all those things. So again, going through the whole thing, I mean, all the way to disinfection. I mean, it's less. You know, this type of technology is probably less valuable as the water gets cleaner and cleaner and cleaner, but not necessarily. I mean, if you want to know, we've seen chlorine levels. We can measure chlorine levels. We can look for toxic metals. We even have some provisional patents that help us find specific metals that are getting toxic metals that are getting into water. So, you know, examples: lead, cadmium, nickel, things you really don't want in your water supply. We can measure those very specifically. So even with clean water, we can tell you something about what's going on and protect people.
And of course, dechlorination is a big part of the waste water treatment process, right? That's, still today, I know that there are plants that are adding more dechlorination to their process for the effluent that's leaving the plant, right? So I imagine your sensor would be very handy in those kinds of applications as well.
Yeah, so the one thing that we even published in an article about this is that our sensor is far more sensitive at lower concentrations than the sort of standard chlorination sensors. So, and we can even calibrate. That's the crazy thing about this, is we can literally calibrate the biofilm signal using known amounts of things like chlorinated water and metals. Again, we've actually published on this. So it kind of goes back to the, you're basically using an organism as your analytical device. And, I told you earlier that we couldn't really calibrate it, but now I'm coming back to that, and I'm saying you kind of can if you are controlling it enough. And so, and we're working on that, but at a very high level, you don't need to calibrate it, but you can calibrate it, I think, is where I want to go with that.
Okay. Yeah, and to me, it's a lot of it is over my head, but it's very very fascinating. Kind of understanding, of course, the cost benefits. To me, it really kind of ring true. But for the typical operator, typical plant engineer, do you need to be a PhD to kind of work with your equipment, or is the information that's provided from your cloud software pretty self-explanatory?
Yeah, it's very easy to use. In fact, what our customers do and what we recommend doing is having a dashboard of all the different probes at the different locations in your plant. And many of our customers will just look at the dashboard and go, "Yep, that look normal. Those are the normal cycles that I expect." Right. And it's really just there as a validation to say operations normal. Right. And so that's really the intention. And what the only time anybody should be concerned or think, okay, now I need to start doing something, is when they see the signals in any part of their process where they have these sensors. If they start to go outside or significantly outside of the normal cycles, something is going on. We've seen things from, heavy dilution events, heavy nutrient events. We've seen pumps go down. All of that stuff causes, all of those operational changes cause the microbes to give you a signal. So you wouldn't necessarily think that this is a biofilm. So that's the crazy thing, is you think, well, the biofilm, it's like all very specific about all the biology and all the nitty gritty details. No, if a pump goes down, if a flow slows, the biofilm tells you so. It's really that straightforward. So it's you can use it as a scalpel, but it's also a sledgehammer. It will tell you when something big is happening, and it will tell you like that. Our systems right now, for most industrial systems, it's about a 5-minute data window resolution, but we can literally go sub 1 second if we wanted to. It's a bit overkill. I would say 1 minute data is probably even overkill, but to know that quickly that a pump is down or that something is really hurting your plant, it's extremely valuable. And where we're focused with that is we'd like to put this everywhere. It's part of the reason why we're trying to keep the offering at a reasonable cap expense and support expense, is because we think it belongs everywhere.
Right. And so going back, just I'm thinking here about your pump application.
Yep.
Typically to have a flow switch, you would need to put it into a pipe, and you need to have that well-developed flow profile in order for it to trigger it's usually a velocity-based flow sensor, right? Mm-hmm. So with your probe, could you put it into, say, a stagnant pond, and the reaction that occurs in that pond that's downstream of, say, a pump, could it pick up the results there, or does it need to be in that pipe?
It depends on it. So if the probe is near where the turbulent water is coming out, if it's relatively near to it, you will get you will get a signal, but the signal is going to be much stronger the closer you put it to the pump, and it's better to sort of bracket the process that you want to look at.
Yeah.
So
open channel, right?
The answer is yes, you'll get a signal, but maybe it's not as good as you'd like. But there are engineering challenges, right? Putting a sensor anywhere near these pumps is, I get it. It's a big deal.
Yeah, I mean, flow, no flow switch is, it's not, it's just nice to have that extra layer of protection, right? That if the switch or sensor fails on the pump or downstream of the pump, now you have an extra layer of protection.
Yeah,
and that's also calculating all of these other things. So it's
exactly
really, really neat, Russell. I think we've probably run out of time. I could keep talking about this stuff because I'm still learning, and it's just, I find it so fascinating, but we should probably wrap things up unless there is some key stuff that we maybe missed or.
Oh, I'm sure there's always more. I mean, we have a Q&A session, and I think people will have, links to my contact information. My
absolutely.
LinkedIn account has those papers. I don't list all the patents, but all the papers are online there. So it's readily available if people want to geek out on that stuff. And I'd love for somebody to reach out to me and for ideas on what we're doing, because the science side is even more fascinating than what we can talk about today. So I'd love for people to reach out and continue the conversation.
Excellent. That's great. I appreciate that, Russell. And so again, thank you so much for sharing. Now, something that we do at the end of every episode typically is we request some kind of donation for the Clean Water Education Foundation. And you and I discussed this a little bit sort of beforehand, but correct me if I'm wrong here, but I believe that you had mentioned that Burge Environmental is willing to donate one of your MyProbe systems to a Canadian research institution.
That's correct. Yes, under a non-commercial license. That's right. Absolutely. That's
amazing. Normally we just kind of randomly select a college to get a free widget, but I think this is pretty amazing when you consider what the technology you have and the total package. So let's talk a bit about how that's going to work, Russell.
Yeah, so my thought is that everybody who's watching this and gets the information about this, I mean, certainly you don't have to watch the whole, from my perspective, you don't have to watch the whole podcast, but obviously if you watch the whole thing and you learn something from it, and you're interested in applying that in your laboratory or in your research projects, please submit an application. I think you'll have our contact information, both Justin and my contact information. I'm thinking, a 4-pager application. I'm not going to ask for any specific format other than, let us know who you are, what you're doing, why this appeals to you, why you think this is interesting, and how it applies to your specific areas of research and the applications thereof. And my hope is that we get a decent number of applications, and then I think I have a science and engineering team that backs me. So I'm thinking that maybe we do and Justin, we can work with you too to help us find the sort of winner. And then the idea is we would probably announce that depending on when they trickle in. I mean, the hope is we get all the applications by the end of this year, so end of 2021. Announce a winner in January, and then deliver the system in the first quarter of 22.
Yeah, and ProLine can assist too with promoting the opportunity to local Canadian institutions that are researching in this area. So we know that the Clean Water, Walkerton Clean Water Center does a lot of great research, and there's other organizations and institutions that we're connected with, and so we'll make sure the word gets out there. But
great.
Yeah, it's been incredible. Really appreciate it, Dr. Russell Burge. Thank you so much for joining us here today on the Clean Water series.
Thank you, Justin. Thank you, Mark. Appreciate it.
All right, take care, Russell.
Bye-bye.